Welcome to my channel, folks. Box of Crafts. Good to see you here. So what's today's video topic? Our primary aim is to guide novices in welding or those who've always been fascinated by it. They sometimes wish to attempt welding, but they lack any experience, no matter the technique. Today's video will start with this. To make equipment selection easier, I suggest specific tools for those keen to learn welding. It's not necessarily costly. In fact, I'm eager to show that for the first time right here. If you've been looking for equipment and are confused by the terms, I'll explain more later. Just know that on the far right, I have a TIG machine for AC/DC welding, and next to it, a multi-welder pulse device. Next, we have the compact gadget. Here we have a direct current device that not only welds electrodes, but also features a high-frequency ignition for the TIG process. Over on the far left, you'll see a MIG-MAG multi-welder that supports both electrode and TIG welding with lift arc. Sure, it may not hold much significance for you now, but that's not always negative. The key question is what kind of beginner welding gear I should acquire for urban use. For those new to welding, I'd suggest a multi-welder. This tool encompasses 3 types of welding: MIG, TIG, and electrode welding. The remaining 2, TIG and electrode, are a bit heavier. First, I'll instruct you on MIG welding, as it's my firm belief. The device I'm holding here is priced at $190. It's safe to say that these devices can range anywhere from $150 to a whopping $1,000. Yes, you could opt for the higher end, but I'd suggest starting with a device around the $200 mark. It's more than sufficient for beginners. Plus, you'll need to account for other costs, such as a gas cylinder. You'll still require a pressure meter and a soldering rod. All comes with a price. Assuming you decide to buy this kind of gear, you'll likely need to spend around $350, but remember, the gas cylinder can be rented from your local hardware store. Will she get it refilled there too? I'd suggest investing in an auto-darkening welding helmet. It frees up your hands, making it easier for beginners to work, unlike traditional welding shields that need to be held. What else is required? Ideally, UV safety glasses. Shield your eyes slightly. To avoid any potential harm, it's essential to wear UV protection cream, welding gloves, and ideally, full welding attire. Closed work shoes are also necessary to prevent any splashes from penetrating. In essence, avoid wearing sandals as they could lead to severe injuries from splashes, a situation that's entirely preventable. Indeed, it's crucial to know that the fumes from welding are harmful, and UV radiation can harm your skin. Make sure to apply UV protection cream prior to welding, and always work in areas with good ventilation or equipped with extraction systems. Vest! No need to jot down or remember all the gear I've mentioned. Check the video description. I've put all the links there if you're curious. Sure, I'm eager to teach novices about MIG welding or metal inert gas welding, which also includes the MAG process. Just once. In the process of metal active gas welding, I utilize an active gas, specifically CO2 in my scenario. This gas is dynamic and it's mixed with a bit of oxygen. This leads to a reduced oxygen presence in the gas, actively contributing to my welding procedure, for example, by increasing the temperature of the weld pool. Indeed, there's also this method called metal inert gas that incorporates a gas. This is internal, meaning it doesn't meddle with the procedure. It's nearly unbiased. This just protects me from the air, making sure the sauna doesn't mingle with any oxygen, thus efficiently getting rid of my sweat. Yes, can you explain how it operates? Indeed, I possess a coil of wire. The wire from this coil is channeled into this conduit, if you will. So the cable goes here then. I've just disconnected the hose pack link that's running here. In there then. Here's another spiral, also termed as the soul. This Bowden cable functions much like a bicycle, with a wire coiled in a spiral. Picture it in your mind. Plus, it's versatile. You can swap it out with plastic, among other things. But I'll tackle that in a separate video, as it's too much for now, all right? Let's put the wire in here now. Reconnect the hose unit. What? I'll activate the machine for you to advance the wire. The wire threads through this tube coming out at the gun's front, and I can control the whole system from this point. Start here with this gun. Just a moment. The elevation we must attain here ranges from 2 to 250 meters. Here's the wire. Explaining the whole welding process is straightforward. I use a welding machine with a negative and positive pole. In this case, my hose pack is positively charged. I also have a grounding clamp that I can attach to my workpiece or welding table, depending on my needs. Here's the full view, my ground clamp. I'm attaching the pole to this negative terminal. There's still a chance. Also, fuse the flux cord wire here. Naturally, I must always distinguish myself from Poland, implying I'd have a toolkit that doesn't include Poland. Ground clamp for the positive pole. At present, we're welding a typical MAC, necessitating the poles to be welded with the ground clamp on the negative side. Now, I'll fix it to the base of my bag table, step by step. Once my shielding gas is activated, I'll be set. This is due to the fact that the moment I press here, the solenoid valve opens, initiating the flow of the shielding gas. At the same time, I'm also getting power at the wire tip. Now, even if the machine is off, it occasionally turns on when I flip the switch. Is there anything going on here? The current only turns on when I hit the button. This is how the entire process functions. When I apply pressure to the wire's tip, it results in a short circuit, generating an electric arc. This wire is then transported during the pressing procedure, which can be visualized as tiny metal droplets descending and scattering. A pool, or rather, a volume of liquid metal. All I need to do is smoothly guide this metal along the seam gap or wherever I want to weld, using the right welding tool. That's the main idea. Let's now discuss the extra things we require. This is the pressure lowering device. Typically, my bottle can hold up to 200 bars. However, there are also bottles that can accommodate 300 bars. So this would be suitable for a 300 bar bottle too, even though they usually hold 200 bars. Why do I require this type of pressure reducer? Naturally, I can't utilize the substance from this valve for welding tasks. I must set the pressure regulator so low to prevent everything from blowing off, making it suitable for welding. Indeed, the current pressure in the cylinder is shown on the left side. 0 signifies emptiness. You can also observe the amount. Should he purchase a new bottle, it's on the right. I then tweak the gas flow rate there. The basic principle is per millimeter of wire thickness. When I'm welding with a millimeter wire, I use about 10 to 12 liters. Sure, position the needle between 10 and 12 and you're surely on the correct path. Thus, if you aim to weld to the fullest, don't you recognize the type of bottle you're holding? You can always glance down here. The name, usually a company's, can greatly differ based on the gas manufacturer type. Yet the crucial specifics are penned in tiny letters down here mentioning argon. 18% is the percentage of carbon dioxide. This is the precise gas required for MIG welding. Yet it might also suggest a composition of 92% argon and 8% oxygen. Naturally, it also allows for welding. These are the two gases perfect for this task. Wrapping up our initial MIG welding video, let's delve into the gas nozzle and the contact tip. The gas nozzle's main role is to distribute the shielding gas that emanates from it. Why do we use a bell to cover the weld pool, keeping the atmosphere away from it? I can manage the gas pump. Sealing a deal becomes tougher when it's on the brink of collapse. The gas nozzle is hidden here, just like this. A bronze cuff. It has holes for the shielding gas to escape. There are multiple, so always keep it clean. If blockages exist, the gas won't spread as before, causing an issue at the top. The contact tube or contact tip ensures the wire is consistently powered. This is why it's vital to have the right component. For example, you've now attached an 08 wire or wire roller with 08 wire. In this instance, I'm using a 1.2 contact tip, which, as expected, has a significantly larger hole. It swings to and fro. I'm placing this here. It's oscillating, causing unstable contact, making proper welding impossible. I quickly notice it's merely stammering and spluttering indeed. Contrarily, if I use a 1mm wire with a 0.125 nozzle, the result is quite different. Sometimes, depending on the nozzle type, the wire slips through and I get caught off guard when it gets stuck. Indeed, these are crucial points that you should certainly focus on. Okay, so we've come to the conclusion here. I trust I've imparted new knowledge to you and you've gleaned insights. Feel free to comment if there's something else you'd like to see or any other requests you have. Indeed, as mentioned, giving a thumbs up or subscribing would be appreciated. Ensure you're subscribed to not miss out on my upcoming video about max welding. Be safe. Goodbye.